Hello guys, my name is Sai Venkatesh and my operating system's topic is virtual memory. What is virtual memory? The term virtual memory refers to something which appears to be present but it is actually not. The virtual memory technique allows user to use more memory for a program than the real memory of a computer. So, virtual memory is the concept that gives the illusion to the user that they will have main memory equal to the capacity of secondary storage media. The concept of virtual memory. A programmer can write a program which requires more memory space than the capacity of the main memory. Such a program is expected by virtual memory technique. The program is stored in the secondary memory. The memory management unit (MMU) transfers the currently needed part of the program from the secondary memory to the main memory for execution. This to and fro movement of instruction and data parts of a program between the main memory and the secondary memory is called swap. Address space and memory space. Virtual address is the address used by programmer and set of such addresses is called address space or virtual memory. An address in main memory is called a location or physical address. The set of such locations in main memory is called a memory space or physical memory. This is a diagram of virtual memory. Virtual memory content. CPU generated logical address consisting of a logical page number plus the location within the page. It must be mapped onto an actual main memory address by the operating system using mapper. If the page is present in the main memory, CPU gets the required data from the main memory. If the mapper detects that the requested page is not present in main memory, a page fault occurs and the page must be read from secondary storage 4,5 into a page frame in main memory. Address mapping using memory mapping page table. When the requested page is not available in the main memory, we can see that the page fault have been occurred in the main memory. Then the virtual address generated by the CPU is used to take out the requested page from the secondary storage media to the main memory to remove this page fault. If empty page frame is not available, then a page must be removed from page frame in main memory. Page replacement algorithms. In a computer operating system, the uses paging for virtual memory management. Page replacement algorithm decides which memory pages to page out, swap out, write to disk when a page of memory needs to be allocated. Paging happens when a page fault occurs and a free page cannot be used to satisfy the allocation, either because they are none or because the number of free pages is lower than some threshold. First in, first out, FIFO. First out is a very easy to implement. The first in, first out algorithm selects the page for replacement that has been in memory the longest time. When a new page must be loaded, the page recently brought in is removed. The page to be removed is easily determined because its identification number is at the top of the FIFO stack. The FIFO replacement policy has the advantage of being easy to implement. It has the disadvantage that under certain circumstances, pages are removed and loaded from memory too frequently. Consider a paging system having capacity of 3 pages. The execution of program requires reference to 5 distinct pages P1, P2, P3, P4, and P5. The pages are executed in the following sequence: P2, P3, P2, P1, P5, P2, P4, P5, P3, P2, P5, P2. Least recently used LRU. The least recently used page replacement algorithm keeps track on page usage over a short period of time. The LRU algorithm can be implemented by associating a counter with every page that is in main memory. When a page is referenced, its associated counter is set to 0 at fixed intervals of time. The counter associated with all pages presently in the memory are incremented by 1. The least recently used page is the page with the highest count. The counters are often called aging registers as their count indicates their age, that is, how long their associated pages have been referenced. Hilario algorithm. Optimal OPT. The optimal policy selects the page for replacement for which the time to the next reference is longest. This algorithm results in fewest number of page faults, but this algorithm is impossible to implement. At the time of page fault, the operating system has no way of knowing when each of the pages will be referenced next. However, it does serve as a standard against which to judge other algorithms. Optimal. So, let me just revise what we have learned. We have learned what is virtual memory, the definition of virtual memory, the concept of virtual memory, address space and memory space, the diagram of virtual memory, including page frames, address mapping using memory mapping page table, page replacement algorithms, first in, first out, the first in, first out algorithm, least recently used, least recently used algorithm, optimal and optimal algorithms. Thank you. I would like to end my session here. Thank you everyone for watching.